Okay. I'm in focus. Okay, I think things look like they're supposed to, like they're functioning properly. Okay, so we'll get going here. So a couple things about the upcoming material. So there's this section. Let's see, when was that? Here's how I want to handle these two sections coming up. Oops, let's move that over. Can adjust that when we do some work. So we've got some stuff coming up in Delta Math. There's the compound inequalities. So inequalities coming up. We're going to cover exponents today, and then we're going to get into the inequalities, absolute value equations, absolute value inequalities, that kind of stuff. And then we're going to get into, whoops, that's too much due in the middle of October. I might have to adjust these due dates a little bit. But basically what I'm telling you, what I want to get at is at the end of chapter 5. So see, I'm here in chapter 5, which is all about polynomials. When we get to the end of chapter 5, will be an exam. Okay, so that will be, some people call it a midterm exam. It's just an exam in the middle of the semester, basically. So, so that's when you can expect your exam. Now, what will the date be of that exam? I don't know. It's too far off. And, it kind of depends on how we move through things. So depends at that pace. You kind of want to be flexible with the class so that if people want to ask questions, we have time to do that, or we can move at a pace that makes sense. So I don't know the exact date of when that exam is going to be. If I had to guess, it would be in the second half of October. So maybe about a month from now. So you can expect to have an exam in this class approximately a month from now. It will cover the material that we've covered so far in the class. So it'll go back and it'll cover everything that we've covered so far. So you can just go back to the earlier modules and look, oh yeah, it's gonna include systems of equations. It will include graphs and graphing equations of lines. We've got some inequalities to talk about, and then exponents, polynomials, and factoring. So those are all things we have to cover in the next month. We'll see. It might be shortly after the middle of the month when we have the test. It might be closer to the end of October. It just depends on where we get in the class meetings between then and now. Factoring is really important, so I don't want to rush factoring. If there are two topics that you leave this class with that you absolutely are going to need in your future classes, it would be being able to deal with linear equations, so graphing lines, solving linear equations, stuff like that. Use that in everything, including statistics. And factoring is absolutely necessary for those of you who are going into college algebra, pre-calculus, trigonometry. If you're going the calculus route, then you're gonna really you have to just have that factoring down, like the way that seems like some schools still do it, some schools don't, where they drill like your multiplication tables. Like when someone asks you what's 5 times 8, you don't sit there and count out 8 5s on your hand, right? You just know, 8 times 5 is 40, right? You know that immediately. You have to be like that good with your factoring if you're going into college algebra, trig, pre-calc, calculus, any of those classes. You have to be really good with the factoring. And honestly, it's one of those classes where if you get into the next class, so like some teachers on the first day of class give a quiz, and that sounds weird. Like, why would a teacher give a quiz before you've even learned anything? What they do sometimes is they're giving you that quiz to figure out if you should really be in the class. I don't like that kind of. It doesn't work for me because sometimes students just haven't looked at math in 2 years. That doesn't mean they don't belong in that class. But to each their own, right? For different professors do different things. But a lot of times, if you can't factor at the beginning of the class, they're going to recommend that you go back to Math 3, right? We have teachers who do that. So you want to be really good with the factoring. Those are like the most important things. So when we get to this chapter 5, we're going to slow down, especially the factoring part. We're going to slow down and give you some time to get used to it. In the meantime, We're going to cover exponents, and then I'm going to go a little bit over the inequality stuff, but I'm going to be honest. I'm not going to spend a huge amount of time on inequalities without being prompted, because basically what I will do, like if I take up some class time, is just repeat what's already in the videos. So like if you go in here, see how there's already some videos here that were made by me about solving absolute value equations. All I would be doing is literally just repeating those types of problems. So there's really not much. I'm going to, like, some of these things I can add some context to and give a larger flavor so that you can kind of see how everything fits together when we talk about, the math topics. You'll go, yeah, some of what he said in class is a repeat of what's in the videos, but then he added this other stuff. When it comes to this section, what I have in here as the 4th module, or the chapter 4 module, there's not a lot for me to add to those videos. Like I've made those videos pretty clean cut. So go through and watch the videos that are in Canvas. Now, if you have questions, that's fine. I can make time to answer your questions. So if you send me an email and you say, here's a screenshot of the problem I'm having trouble with on the homework. I watched the videos and I'm trying to do this, and here's what I'm getting, but my answer is incorrect. It keeps telling me I'm doing it wrong. What am I doing wrong? If in that kind of a case, I'm happy to go over it. But it should kind of be directed so that I know what it is you're having trouble with. If you just say, I don't really get absolute value equations, give me a better question than that. I'm trying to do this absolute value equation. Here's a screenshot of the homework problem, and I keep getting this answer. What do you think I'm doing wrong here? I keep trying to do it this way. Like show me, like you fill in the details. Don't just say, oh, I don't get it. Like fill in the details. Give me an example of what you're working on, because then I can give you directed information, and maybe go over a couple of them in class if students are having trouble. Some students have done these homeworks already and they're done. So I don't want to spend time on stuff if students are good with it, right? What's the point of me talking about something that you already know? We should be talking about things you don't know. So feel free to send me questions from this chapter 4, and that's probably how I will discuss most of that, because otherwise, like I say, just watch the videos, right? They're in my opinion, that's all I would be saying in class. But if you have a specific question, then I can answer that specific question and go, oh, I see what you're asking about. Let's look at that and go over it. Okay, so we'll do that. We'll get through the chapter 4. When we get through chapter 5, which probably will take about at least a month probably, we'll have the exam. So there's a question here. Will you give us a few days for exam prep and review? Will you dedicate one class to review? Yeah, so we can do that. Generally, what's going to happen for the exam is you'll know that I'll give you roughly the dates about a week ahead of time. So you kind of know, because as we move through chapter 5, you'll go like, okay, we're almost done with chapter 5. That test must be right around the corner, right? At the beginning of chapter 5, you're like, well, we still have some time. And we're doing it a little bit out of order because I'm starting chapter 5, but I've also said I can make time to go back and talk about these if you send me specific questions, like guided questions, like this is exactly the type of thing I'm stuck on, then I can address that. But otherwise, we're moving through chapter 5. So the further we move through chapter 5, you know that test is coming, right? You know it's around the corner, so you can start preparing for it. So what are the things that you should be doing as a student to prepare for a coming test? Well, some of you are totally caught up on the homework. Fantastic. Keep that up, and you'll be just fine, right? The students who are always caught up on the homework are generally the students who get an A in the class because they're sort of taking care of everything right away. Most of those students get A's. Some students have fallen 1 or 2 assignments behind. That's okay, right? Don't panic about being maybe even 3 or 4 assignments behind. You're okay. If you're like all the assignments behind, you haven't really done anything, then it's going to get hard. But stuff happens. We live in a weird world, right? We have people's lives are in a bit of chaos because of the pandemic, and people's job situations have been disrupted. People's home lives have been disrupted. Many of you have parents and kids. I get it. You get a couple assignments behind, no big deal. But now is the time to start getting caught up, because being 4 assignments behind now isn't really that big a deal. Like, it's doable. It's not great, but it's doable if you start doing it now. What you don't want is there to be a couple days left and you have like 4 assignments behind. That all of a sudden is going to suck up all your time that you need to get ready for that test. So what you want to do, if you're a few assignments behind, start working on them now. Because what you can do is keep doing the homework that's new that you need to be doing, and then each night just spend 15 minutes on a past homework that you're behind and try to get that caught up as well. And what will happen is if you keep doing that, in a week or two, you're going to go, oh, I'm like totally caught up now. I'm good. And then it's no stress, right? So now is the time, if you've fallen behind, now is the time to act on that and start getting yourself caught up. What happens is a lot of students let stuff go, and then they're like, I'll just take care of it all in the last 2 days. There's a lot of problems with that. One is a lot of times they don't get caught up. They're not able to complete the homework assignments on time, so that hurts your scores. You also aren't going to retain it as well. Okay, you can go on YouTube and you can watch videos of the brain forming synapses when you're learning stuff, right? When you learn things, your brain is physically changing. And a lot of times people don't realize this because we're used to thinking, right? And sometimes our thoughts get away from us, right? That's why people practice meditation and stuff like that, so you can start to learn to like train your mind and how it thinks and be more in control. But we sort of think of this thinking as some kind of like thing that's not connected to the physical world. You can watch videos of the brain physically forming things, its structure, when you learn things. Well, anytime a physical process is going on in your body, that process, has like an efficiency it works at, and then it starts to level off. So what happens is, and this is true for almost everything, right? In fact, as far as I know, it's good for everything. You learn best. The research shows you learn best in short chunks. 1 hour, 2 hours, stuff like that. Once you go beyond 2 hours, your learning drops off. You might still be able to do your work. You might still be able to conjugate verbs in Spanish class, and you might still be able to like finish your rough draft, and you might still be able to do the homework assignment. But this is where the next day I have students coming up and going, man, I knew how to do this last night. I did the homework assignment, and now I don't remember any of it, right? Because you were working in hours like 4 or 5 where your brain was fatigued. Your brain got worn out, and it wasn't forming those synapses in the same way it was in the first hour or two, right? You hear this, those of you who have practiced musical instruments, you never had a teacher say, ignore your musical instrument for 6 days, and then on Sunday just do 7 hours of playing. You've never had a teacher say that, because that's the wrong way to learn something. It's the same thing in a math class. That's the wrong way to learn a math class. You want to be working on it every day in short chunks. If you're behind, that's fine. Just add a little chunk to each day that'll get you caught up. Because what you don't want is what you want in the last 2 days is to be going over the material that you're confused about. If you have undone homework assignments, this happens all the time. I see students working on homework assignments that they actually know how to do. They know how to do those problems, but they need to get the points for the homework. So they're working on the homework instead of working on the problems that they're not sure how to do. You want to, in those last couple days, you want to be working on the stuff you're not sure how to do so that you can get it right on the homework. That's totally silly. I have 1 day left to study for the test, and I'm working on stuff I already know how to do just so I can get some homework points. That is a bad strategy. So get caught up on your homework now. And then what's going to happen is I will give you a practice test. The practice test, I want everyone to know, is not necessarily exactly like the test. Sometimes it's very, very similar. Sometimes it's just kind of similar, right? I reserve the right to change problems. Sometimes a student might say, well, this wasn't exactly like a problem on the practice test. I am not guaranteeing that the practice test will be a carbon copy of the actual test. So be prepared for that. Be prepared for me to take, there might be one type of systems of equations problem, and then I replace that with a different type of systems of equations problem. You need to be ready for that kind of stuff, okay? The practice test is to get you used to the format, because the tests that you take online will have a little bit different format than the homeworks you've been doing. They'll be structured a little bit differently. You're likely to have a written portion that you have to upload for me to look at, and then you're going to have the computer portion, right? That'll happen that way. I tend to give long testing periods. So in other words, people cheat, right? And hopefully you will want to be ethical and not cheat on this class because you actually want to learn stuff. And I find that especially online, if we make the testing situation really brutal and stressful, students are more likely to go cheat. Okay. There's actually not a lot of reason for you to cheat. There's kind of a safety net under this whole thing. So why not just try to do it the right way? Why not just try to do it ethically, right? So it's not like I'm going to give you, 35 minutes to complete this test. You're going to have a big time period. So you're not going to feel rushed. You're not going to feel like, oh, I've only got 3.5 minutes to do each problem so I can get it all done in time. And then you're tempted to just go put it into, some app that's going to figure out the problem for you. Try to work through it, right? You'll have multiple hours. So if you pick a day and time that, the kids aren't asking you to make dinner and you don't have to take your grandparents somewhere to take care of stuff, just pick a time when everyone's going to leave you alone and you can just focus on the mathematics. You'll have a practice test to work through. The way you should look at that practice test is it's feedback on what you know and what you don't know. A lot of times there's an attitude from students that go, I learned this 2 years ago, right? They'll literally say this in class. I'll give them a problem and they'll be like, I did this 2 years ago. Okay, well, can you do the problem? No, but I learned it before. Okay, well, it doesn't really matter if you learned it 2 years ago if you can't do it now, right? So you want to get away from that line of thinking, which is, I've seen this in the classroom before. I don't need to look at it now. It's a question of, can you do the problem, right? So that's what happens sometimes with that practice test is you'll run across something that was easy 6 weeks earlier, but you haven't looked at it for 6 weeks. So you forgot how to do it. That's okay. That's what the practice test is for, is you go, oh, I knew how to do division with scientific notation, but I haven't looked at it for a month, so I forgot. And that practice test is reminding you, oh, you better go back and look at scientific notation division problems to just remind yourself how to do it. And sometimes it takes 2 minutes. You go back, you look at the division problem and go, oh, that's right. That's how you do that type of problem. Now I remember. And then you're good to go for the test. You're not going to miss that problem on the test now, right? So don't think of the practice test as well, it's worth 20 homework points, so I better do it. Don't even worry about that. The practice test is about getting you ready to get problems right on the actual test. That's what you're looking for. Don't worry about points on the assignment. Think about, how do I make sure that I know the material to get stuff right on the actual test? Okay. So you'll go through the test. You'll use it as feedback to yourself to figure out how well you're doing and what you need to do and so on. Then you'll get ready for the test. A day or two later, I usually give you a little bit of a window so you can take it when you think it works for you. Some people are going to take the test first thing in the morning before they have to do stuff. Some people are going to take it late at night after the kids have gone to bed, so they won't be distracted with stuff that's going on. You take it when you need to take it, and then you go through and you do your best on the test. And again, you don't really need to cheat, because even if you do poorly on this first test, you get a chance to retake it. Okay? So don't run to the apps to do the problems for you. Just see what you can do. Test yourself. See what you're made of, right? Are you an ethical person who doesn't need to cheat? Are you someone who's willing to give it a try and actually try to do things the right way? Right? Try to look at yourself and see, do I have these characteristics in me? Especially since you've got this safety net. If you completely bomb the exam, you go, you know what, I'm going to do this ethically. I'm going to try what he says about trying to do things the right way. I'm going to see what I can do. And you totally fail the test. Well, a week later, you get to retake it. So you're not really risking much. You're not really risking anything in trying to be the right type of person, right? An ethical person who's doing things the right way and not cheating their way through. So that's how that'll work. There'll be a practice test, a test, and a retake. So that's quite a few chances to get yourself prepared. Really, what you want to do in the meantime is make sure you're not behind. It's the best thing you can do. Students underestimate how important it is to be caught up as you approach an exam. But like I mentioned earlier, you getting caught up with the homework in that last week will keep you from being able to do the proper kind of studying to make sure you do well on the test. Let's see. Delta Math does not let you jump. So there's a question here. Delta Math does not let you jump around, skip a problem, and go back to it. Will we be able to skip problems on the text and then go back to them? I think not. I think for the Delta Math, I think I'll have to remember. There's different settings, and off the top of my head, I don't recall. You might not be able to jump around. I don't recall. There's likely to be a written portion and a online portion. So part of it will be in Delta Math. Part of it will be like you were on campus. Like I will have I'll leave a posting here where I have a page of problems. And it won't be a ton. It might, I don't know, 2 to 5, something, somewhere in the neighborhood of 2 to 5 problems on this written page. And this will be on, and I'll give you a practice version of this as well. But you'll print it. You'll do your work on it. Like I want to see your work. I want to see you actually working the problem out. I want to see how you're doing it. You're going to upload that by either taking a picture and uploading it. Like, yeah, I'm sure almost all of you know how to upload something to the internet. If not, get a hold of me. But you'll upload that. So I'll have a written portion that I'm grading, and I want to see all that work worked out. And then you'll have a computer version where I obviously I can't see that much of that. Your actual work. I'll see your answers. Let's see. So Ann says, I like to go through and work on what I know and then go back to the ones I'm not certain about. Yeah, people have different strategies for tests, and that's a totally legitimate way of doing the problem. I can't remember if there's a setting. Like even this semester, I'm using a couple different platforms. So unless I'm looking at the settings, sometimes I forget what I can do in one platform, which is what I can do in the other, because they always change. Like not only are they different from each other, but from year to year, they all change what you can do in them. So I can't remember. You might not be able to jump the problems and go back and forth. But hopefully if you're comfortable with them, that won't really be a problem by then. And I don't get tricky with my tests. Those of you who have had me before know I'm not going to give you surprises on the exam, right? I know some teachers pride themselves on really, really hard exams. I tend to not think that's such a great way to teach. I don't see the point unless you're talking about like, super high level engineering and you're trying to even then, I don't know, I'm not sure what the point is. But I'm not going to give you like super hard tests. They're not going to be surprises. You're not going to look at a problem and go, where did this come from? If you see a problem on the test, it's a problem we talked about in class, or it's a problem that came up in the homework, or a slight variation of those things, right? Sometimes you have a teacher that puts a whole new thing on there, and then they're like, oh, well, if you just do this, 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 and this, then it's real easy. But if you've never done that type of problem, it's not, in my opinion, it's not really fair to put on a test, right? So you're not going to see anything tricky. This class, this Math 3 class, I just want to know, are you ready to go to the next class, right? Did you learn the materials that's going to help you be successful in the next course that you take, whether that's statistics or college algebra or pre-calc or whatever? I'm just looking for, did you learn the material? Okay? So keep that in mind. When we get through Chapter 5, there'll be a test. I suspect that's about a month because I suspect some of you are going to send me some questions from here so we can spend some time on that. And then by all means, if there's a day, like if you all sort of think there's a day we need to spend on review before the test, I'm fine with that. But the review needs to be student driven. Is generally how they do them. Because if I just come up with problems, I don't know that anyone even needs to see those problems, right? I could spend 15 minutes talking about one problem, but everyone in the class knows how to do that. So if we decide to have a review day, I'm totally cool with that, but you're all going to have to send me in questions, right? So it's kind of that same thing I always ask for. Give me a screenshot of the problem, explain what you tried to do, and then maybe why you think it's not working, and then I can look at it and go, oh yeah, it's okay, let's go over this. This is a good problem to go over, okay? You definitely are going to see factoring on the test, right? You probably will have a bunch of factoring problems. You might have 10 problems just factoring, okay? All the different types of factoring, because I really need to test that. You will, in all likelihood, have to graph a line. I almost always put on a test that problem that says it gives you 2 points and says find the equation of the line. But all right, was that this class or the other class? Yeah, we did lines and slope and stuff. Finding equations of lines. Yeah, so you're likely to see that problem that says find the equation of the line that goes through these 2 points. That's almost always on there in this chapter. And you'll definitely have some systems of equations that you need to go through and solve. I will not put 3 variable systems of equations on the test. That won't be on there. But you will have to solve systems of equations algebraically, and you will have to recognize when you get one solution, when you get lots of solutions, and when you get no solution. You'll have to recognize those outcomes. So nothing tricky, just sort of going over the stuff. Okay? Any other questions before we get into some discussion of exponents? Okay, so exponents are important. Why are we talking about them right now? Because we're about to talk about polynomials. And polynomials have exponents in them in general. Technically, you can come up with polynomials that don't, but we sort of dealt with those in a different way. So we'll have that discussion in a few days, depending on if we spend much time on inequalities or not. Exponents seem real simple. Right? At first you go, yeah, an exponent's real simple. 5 to the third means 5 times 5 times 5. It just means how many times you're multiplying your 5 out. And it seems simple, right? But what happens is we get into algebra that gets further and further away from the definition. And it gets further away from the definition, and it's not always quite so obvious what you're supposed to do in the different situations with different exponents. So I'll try to, we'll do a quick review, right? So you probably saw rules of exponents in your beginning algebra class. We'll review them a little bit in here, because if you're doing, like, basically the big thing, the big one is when do you add exponents and when do you multiply them? If you're doing the wrong thing with polynomials, everything you do is going to come out wrong. So you need to really get a hang of when do I add exponents, when do I multiply them, okay? And it's actually really easy to just figure it out for yourself. Students don't like this because they like to memorize things. But again, in mathematics, like, many of you have learned to memorize things in your math class, but actually that's keeping you from actually learning the material. What you want to be able to do is come up with a quick little example and remind yourself. So I'll show you how to do that. Let's see. Let's go. Here. Okay. So first exponent rule. Let's say I've got a to the m times a to the n. What does that equal to? So notice I've got the same base. The base is a. It's a little bigger. A little easier to see there, I think. Let's try it. What if I do this? No, it adjusts for it. Okay. If I make the screen bigger, it actually adjusts and makes it smaller. It just makes the code part bigger. Okay, so what do I do here? Notice that our exponent rules have to do with where the base is the same number. When we start taking, the base, one base to a power and a different base to a different power, that's a whole different ballgame. Our exponent rules, they apply when we are using the same base. So notice that it's a to the m, a to the n. It's the a is the base in both cases. So what would this look like? Like, we don't know what that rule is, but let's ask ourselves. Let's see if I can just figure it out by doing an example, right? This is what I want you to be able to do, because 6 months from now, you're not going to remember how the different exponent rules work. But if you can make yourself a little example, you can go, oh, that's right. That's how you do it. So let's say we have x cubed times x squared. And you're sitting there and you're wondering and you're going, I know I had a rule where sometimes I add exponents, and then we had another rule where sometimes I'm supposed to multiply exponents. I wonder which one I'm supposed to do here. Well, just break it down in terms of what does an exponent mean, right? So let's break it down. What is x cubed? Well, that's x times x times x. And what is x squared? That's x times x. So really, one way of considering x cubed times x squared is just this expanded form. So I have 3x's being multiplied and then 2x's being multiplied. So how many x's do I have being multiplied here? Well, that should really just be the definition of x to the 5th, right? Okay, so then if I wasn't going to do it this long way, should I be adding the exponents or should I be multiplying them? Well, 3 times 2 is 6, which is not 5. But 3 plus 2 is 5. Oh, it looks like I'm supposed to add the exponents together. So see how this little example like helped us? Sometimes you want to be able to do this. Sometimes students, when they forget what they memorized, they're kind of helpless at that point, because if you're relying on perfect memory, good luck with that. But you're relying on perfect memory, then when the memory fails you, if you don't understand, you're out of luck. It's like end of game at that point. Here, we did an example and realized, oh, I should just add those together. So this just means m plus n. So I'm adding those exponents together. Okay, so that's the rule. When do you add exponents together? It's when they're in this form. A base to a power times another base to a power. All right, well, since we're talking about it, when is it that I'm supposed to multiply exponents together? Well, let's consider another case. Let's take x squared cubed. Right here, actually, I should leave a little room here. Let me format this a little bit. In fact, let's just go to a different page. And in general, let's look at what our general form would be. So what if I had a to the m raised to the n? And I'll put it on a different line. Okay, well, here, notice how I just made myself another simple example. X squared cubed. Okay, well, what would that mean? What does it mean to take x squared and then cube it? Well, think about the outside part. The cube part means take whatever's in the parentheses and multiply that 3 times. Okay, well, why don't I do that? So this becomes x squared, x squared, x squared. Right? Oh, okay. So that's what x squared cubed means, is I'm multiplying x squared times x squared times x squared. Okay. Well, what do I do here? Well, what did we just learn a moment ago for this type of scenario? This is now we're in a situation where we should add these exponents. Not add the first 2 we started with, but here in this second step, now it's in a form where we can add those exponents and get x to the 6, because 2 plus 2 plus 2 is 6. And then if you look what we have beginning to end, you go, oh, well, it looks like if I multiplied 2 times 3, I'd get 6. Oh, it makes sense. This is where I multiply those variables together. So this is a to the mn. That's the 2 biggest ones. The other exponent rules still come into play, but not as much as knowing when do I add exponents, when do I multiply exponents, okay? So when it's in this form, base to a power times a base to a power, you add the exponents. When it's in this form of a base to a power, that's when you multiply the exponents, okay? And like I say, even if you forget, just make yourself a tiny little example. Work your way through it. Work your way through what that's supposed to be, okay? A couple other kind of weird stuff that you might have forgotten. What's anything to the 0 power? It's 1, right? Technically, 0 to the 0 is kind of a weird case, and it depends on what you're doing with it. But the good news is none of you will ever have to worry about that, unless maybe you become if you become a math major, you might have to deal with it at some point, but even then you probably won't. So you don't need to worry about that. So just anything raised to the 0 power is going to be 1, right? And we can actually, let's create a table here. Actually, let me jump over and remind myself how to make a table, because sometimes by looking at the pattern, you can recognize what's going on with something Let me grab the one I want. Here, let's switch over to this other one. Actually going to show you a pattern here. So give me 1 second to modify this. Oh, I'm going to need a little room here. That should do it. Okay, let's look at a pattern here. Let's see, is that showing up big enough? Oh, that's kind of small. Let's see if I can make this bigger. Okay, that should be a little better. Okay, so we're going to see a pattern here. We're going to have like two to the fourth, and then 2 cubed. And then we're going to have a few of these lines. Because I can show you a few examples from this one right here. So let's do this, and we'll go H line, and then we'll copy this one again. Okay, so we've got 4, 3, 2, 1, 0, -1. Oops, -2. Let's do one more. Okay, so let's delete these. Okay. So I've got on the left my powers of a number. And then over on the right, we're going to look for a pattern in what's going on so we can start to make predictions about, well, what happens if I raise something to a 0 exponent? What happens if I raise something to a negative exponent? What's going to happen? So let's start with the ones we already know. What's 2 to the 1? 2 to the 1 equals 2. 2 squared, 4. 2 cubed, does everyone know where 2 cubed is? This is where I start seeing some students know it, some students kind of forget, but it's not hard to calculate. 2 cubed is 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So 2 cubed is 8. 2 to the 4th then, by the same reasoning, we'd multiply by 2 again, 16. So see what's happening as we go up. Each time we raise that exponent by 1, we double the number that we end up with, which makes sense because you're multiplying by 1 more 2. So you're doubling that thing. So as we go up, we're multiplying by 2. Well, by that same reasoning, as we go down, we're doing what? We're dividing by 2, right? We're doing the opposite. So just by looking at this pattern, you go 2 to the 0. Oh, I don't know what that's supposed to be. That's kind of a weird one. Can't really figure it out from just thinking about the definition of the exponent. But look at this pattern, right? So what would our best guess be? 2 to the 0 should be 1. And that is correct. You raise something to the 0 power, you get the number 1. Okay? All right, well, what if we go further? Now we have negative exponents. What does that possibly mean? See, so now we're in that territory of trying to think about exponents in terms of the definition is starting to fail us, right? Notice how the first two examples I gave you where we walked through exponents, it made sense. But now you're like, wait, negative exponents, so 2 to the negative 3, that means I'm supposed to multiply 2 negative 3 times? How do I multiply something a negative number of times? And then students start confusing the negative in the exponent with the negative in like the problem. Like you can have a negative 2 in the problem, and then you can have a negative 3 exponent. Those negatives are different. They're not part of each other. So keep that straight. Don't confuse those. A lot of times people are used to taking 2 negative signs and canceling them out. A negative in the exponent does not cancel with a negative in the base. Doesn't work that way. But what if we continue this pattern? Well, if every time I move down, it's half what it was on the previous line, then that means my next line should be what? Well, this should be the fraction 1/2. It's not going to compile, right? One half. Okay, well then what if we kept going? Well, you can see how this pattern would go, right? We'd get 1/4, we'd get 1/8, we'd get 1/16. Whoops, this has a typo in it. This should be a 4 here. So you can kind of see what's happening, in fact, with the negative exponents is that whatever we had, like for 2 to the 4th was 16. Well, 2 to the negative 4th becomes 1/16. 2 cubed was 8. 2 to the negative 3 is 1/8. So in fact, what you do is for a negative exponent, you move that term to the bottom of the fraction. Technically, you move it to the other part of the fraction. If it's in the denominator, you move it to the top, it becomes positive. If it's negative in the top, you move it to the bottom, it becomes positive. So let me show you. So in general, we'd say like, say 2 to the negative 3, we would say becomes the fraction 1/2 cubed. Oh, whoops, sorry, it's still in the, meant to do it outside of the tab. See, so 2 to the negative 3 becomes 1/2 cubed. You move that term with the negative exponent, you move it to the other part of the fraction. Here it's really in the numerator. Now it's in the denominator. And at the same time you move it, you change the sign. Right? And it seems like magic. You're just moving things around. What you're actually doing is shortcutting the algebra of multiplying the top and bottom of this fraction by 2 cubed and then simplifying. You're just sort of doing it all at once. Okay? So that's kind of your quick overview of those exponents. There are exponent videos in the Canvas modules. And as always, there are videos that accompany the exponent section on the homework. So I would start doing that. Start working through the inequality stuff. And then as I get questions for it, I'll go over it. But like I said, pretty much all I would say in class is like literally just repeating what I already said in those other videos. So watch those videos, come to me with questions, and I'll help you out based on the questions that I get. We'll go over the inequalities. Otherwise, we will keep moving through factoring. Okay? Does that make sense? So, like always, I'm going to shut down the YouTube stream. Anyone who wants to ask me questions, please hop over into Zoom, and I will answer your questions for you. All right, thanks, everyone.